Hello student, I am Dr.A.K, Professor of Chemistry. Today I am going to discuss a structural representation of organic compounds. Last class I have discussed about organic chemistry, introduction of organic chemistry, some basic principles. I have discussed about some characteristic feature of pi bonds, and also I have discussed tetravalency of carbon. Now I am going to discuss a structural representation of organic compounds. Organic compounds, to understand organic compounds, we should know many things. Then something yesterday I discussed. Now remaining things slowly I will discuss. Structures of organic compounds are represented in several ways. The Lewis structure or dot structure, dash structure, condensed structure, and bound line structure formula are some of the specific type. The Lewis structure, however, cannot be simplified by representing the two electron covalent bond by a dash, a small line. Such a structure formula focuses on electron involved in formation. A single dash represents a single bond. A single dash represents a single bond. Double dash is used for double bond, and a triple dash represents triple bond. Lone pair of electrons on heteroatoms means different. Lone pairs of electrons on heteroatoms like oxygen, nitrogen, sulfur, halogens, etc. may or may not be shown, but it may be attached with carbon. These all this atom, oxygen, they have lone pair of electron. Nitrogen, it has lone pair of electron. Sulfur has a lone pair of electron. Halogen has a lone pair of electron, but may or may not be shown. Thus, ethane is C2H6, CC. Between the CC, one bond, single bond, and each carbon will have three bond, HHH, and other also HHH. Then all are single bond, that is represented by a dash. Okay. DASH dash, a small line that represents bond. Thus ethene is C2H4, carbon double bond, and each carbon two hydrogen. Each carbon have two hydrogen, two bond. Each carbon total four hydrogen and carbon double bond. Ethine, that is C2H2, carbon triple bond. Each carbon one bond with hydrogen. And methanol you can represent like this, CH3OH. CH3 is called methyl group, CH3 with the C3H is there, means 3 bond, 3 dash. Again with CO is attached. O has 2 bond. One bond is attached with carbon, other with hydrogen, CH3OH. Then this can be represented by a structural formula. Just I will try to send some formula, a structure of ethene, I will send, or methanol, I will try to send the formula. Then now what I am telling you, listen very carefully, that it should go in your mind. A structure, ethane, I told you, two carbons are there, C2H6, C2H6, then two carbons, CC single bond, and each carbon has three hydrogen, three bond, okay, each. Then this you can write like that way, a structure that is called open structure. Like that way, ethene already told you, carbon carbon double bond, and each carbon two hydrogen, okay, C2H4. And ethine already told you, carbon carbon triple bond, and each carbon is attached with one hydrogen, that is ethine, also called acetylene. And methanol, already I told you, CH3OH, means with one carbon three hydrogen, and oxygen it is attached with carbon also and hydrogen also, and it has two lone pair of electron. Then simply for methanol we can write CH3OH, just like ethyl alcohol, C2H5OH. Okay, this is the representation of representation of organic compound. Others are also there. Then I told you it can be represented in a many ways. First I told you Lewis structure or dot structure. Second is the dash structure. Third, condensed structure. Fourth, bond line structure. Then now I am going to discuss other way. These just like by line, also by dash also you can show one small line for the bond you can write. Then this is a open structure. But now always you should not write like this way. It will become a big structure, more space will be required. If you write dash, that C and H, between C and H one small line, that is the dash. Then like that way every bond you can write like that way. Then it will require more place to write, and time taking will be also more. Okay. Then other way is there, condensed structure formula. Condensed structural formula. Here you have to not write the dash, simply condense it, make it short. That is the CH3 simply, CH3 for ethane. No bond you have written, you have not mentioned the bond, no dash, simply CH3. This is the example of condensed structural formula. And for ethene, same way, CH2, but here between the CH2 double bond you can write, okay, only with carbon, between the carbon two bond you can write, okay, CH2 and again CH2, and between the two C double bond. You have to not write this bond with H, okay, only with carbon. And CH2 double bond CH2, that is the ethene. En means double bond, last class I discussed. Like that way ethine, write simply CH, between the CC triple bond, CH triple bond. Like that way methyl alcohol, simply you can write CH3OH. You have to not write in details bond, dash you have to not write, simply CH3OH, methanol. And like that way these things, if a chain is long, suppose long, like for example CH3, CH2, like that way, means maybe 7-8 carbon, maybe 7 carbon or 8 carbon or 9 carbon, sometimes 10 carbon also. Then in the beginning and last it is CH3. In the beginning, first carbon and last carbon will be CH3, and in the middle it will be CH2, 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 like that way. First and last will be CH3. Then how will you write these things? This is a long. Then simply you can write CH3, and suppose between the CH3 to CH3 6 CH2 are there. 6 CH2 are there. Then simply write CH3 CH2 whole 6 and then again CH3. Then in a shortcut way, this is the condensed structure formula. CH3 CH2 whole 6 and again CH3. Suppose it was when it was 8. If it is a 9, then CH2 whole 7 you have to write. CH3 CH2 whole 7 again CH3. Okay, like that way you can write. If it is 10, then CH3 between the CH3 8 are there. Total number of carbon is 10, but between CH3 8 are there. Then you write CH2 whole 8, CH2 whole 8 again CH3. This is the way to write. Okay, then this is called condensed formula. Like that way, other you can say this things, other structure is also there. As for example, 3-methyl octane. Suppose you have to write 3-methyl octane. Then how will you write 3-methyl octane? Then what do you mean by the word 3-methyl? Then here actually it will be useful for in IUPSC name. Now when I will teach you IUPSC nomenclature, that time it will be helpful. Then now meaning of, first I will tell meaning of 3-methyl octane. Then you already know that one carbon is called methane. One carbon and 4 hydrogen, CH4, that is called methane. And 2 carbon is called ethane. Saturated, this is a saturated hydrocarbon. Hydrocarbon means compound of carbon and hydrogen. Only 2, carbon and hydrogen. That is called hydrocarbon. Name it, from the name it is clear, hydrocarbon. Then first only one carbon is there. Then CH4, one carbon and only hydrogen is there, 4 hydrogen. Then it is called methane. When 2 carbon is there and rest are hydrogen, then it is called ethane. All are saturated, means single bond. Everywhere carbon has tetravalency. 4 valency, it can make 4 bond. 4 electrons will be total, 6 electrons are there carbon, but outermost electron 4 are there. 1 s square, 2 s square, 2p2. Then 1 s square, leave it, it will not take part in bond formation. Then outermost 4 electrons are there. Then it can make 4 bond. Then that's why it is called tetravalency. Tetra means 4 valency. Then when 1 carbon, then you can write methane, and rest will be filled by hydrogen. Always you have to count 4 valencies there or not. Okay, always you have to count for tetravalency. It must come 4. Then say if 2 carbon is there, 2 carbon, CC, I told you, carbon single bond, and then CH3 you should write, then it is called ethane. Then 2 carbon, then it is called ethane. If 3 carbon, then it is called propane. And 4 carbon is there, then butane. 5 carbon, pentane. 6 carbon, hexane. 7 carbon, heptane. HEPTANE. Always ANE in the end it will come, ANE. And 8 carbon, octane. OCTANE, octane. 9 carbon, nonane, N-O-N-A-N-E, nonane. 10 carbon, decane. This I have told you in a general way, simple hydrocarbon I told you. It can go up to carbon 40. But if it is saturated, means always it will be, each carbon will have single bond only. If each carbon has a single bond, then it is called saturated. And when any carbon has a double or triple bond, then it is called unsaturated. If double bond is there, suppose one double bond is there, then it is unsaturated. If one bond will break, out of two, one bond will break, general pi bond will break, then it can join with two hydrogen, then one bond will break. One bond means two hydrogen. Hence, if one bond will break, means two carbon will be there. Each carbon will take one carbon. And if hydrogen will come, two hydrogen will come with one carbon, then they will join and they will make bond. Then two hydrogen bond will be formed. Okay. Then it will be now everywhere single bond. Then this is called saturated. Saturated means single bond everywhere. This you don't forget. Then now I was telling you about the meaning of 3-methyl octane. Then octane, this is the main. Octane you write means 8 electrons are there. In that compound 8 electrons are there. In this hydrocarbon 8. And just you write 8 electron. Carbon, total 8. And all you join by single bond, all carbon. Then last two carbon, beginning and last, they will have 3 electrons are now remaining. First carbon and last carbon, 3 electrons, and 3 bond can be formed with hydrogen. Then it will called CH3. First CH3, last CH3. And in the middle all carbon, because all carbons in the middle are joined by left and right by one bond. One bond means out of 4 valency, 2 valency is used up. Then now 2 valency is remaining, means 2 electrons are remaining. That's why 2H you can write, 1H up, 1H up, 1H down. Everywhere same things. CH2, 1H up, 1H down. Again 1H up, 1H down for every carbon in the middle. Correct? Then you will find like this, CH3 and the beginning, CH3 and the last, and then 2 carbon, then in the middle 6 carbon will be there. CH2. Then now that you count from any side, left side or right side, total 8. From the first to last, total 8 electrons are there. Then now on the third carbon, you have written everywhere CH2. Now this H, all H can be replaced by other group. This is again important things. All H from the beginning to last can be replaced by other group. Then other group means what? I am just giving just some idea. Okay. Details when at right place I will tell you. As for example, OH group, that is called hydroxyl group, OH. One H will go, in that place one OH will come. Then from the compound one H gone, means any particular carbon, one hydrogen gone, in its place one OH has come. This is the alcohol group, alcoholic OH, alcoholic group. Like that way CH3 group may come, CH3 methyl group. Methane is there, na CH4, one H will go, then it will come, it will be called YL. From the methane one hydrogen gone, then only 3 will be there, CH3, and one carbon, with one carbon one valency will be left out, one electron. So that you can writing like one dash. Okay, then that is the called methyl group, CH3 and one small dash, means one electron is there, it can join with others. Then methyl group, like that way ethyl group, C2H5, one dash. Ethyl group means carbon has one electron, it can join with others. Then methyl group, ethyl group, if 3 carbons are there, then propyl, C3H7, C3H7, it is complete saturated, but one hydrogen will go, then it will form propyl. Then like that way propyl, with if 4 carbons are there, then butyl, pentyl, hexyl, heptyl, octyl, nonyl, decyl, like that way YL will come in the end if one hydrogen is less. Then like that way one is the carboxylic group, COOH, this is called carboxylic group, and one dash will be there with C, one electron will be left out, then it is called carboxylic group. Like that way NH2 group, NH2, one electron will be there, it can make bond, then that is called NH2 group, amine group. Like that way NH2 group may be there, NH group may be there, NH also group will be there, amine, amide, and like that way chloride may be there, chloride, Cl1 dash, Br1 dash, chloride, bromide, iodide, I1 dash, fluoride, F1 dash. Then like that way these are also group, fluoride, chloride, bromide, iodide, these are group. Like that way COO, ketonic group, also called carboxylic group, CO group is called carboxylic group. Then it will have one side 2 valency will be remaining. In CO group 2 valency will be remaining, left side, right side, one dash you can write. Then this is called carbonyl group, CO group, C double bond O, and left side 1 dash, other side 1 dash. Then this is CO group, carbonyl group. Like that way aldehyde group, this is also called ketonic group, CO group is also called ketonic group, and aldehyde group means CHO, one hydrogen will be there, CHO 1 dash, because with other dash one hydrogen came, it was both side 1 CO group was there, both side 1 you can say dash was there, 1 electron, then now one hydrogen joined there, then it became CHO group, aldehyde group, CHO, ketonic in both aldehyde and ketonic group, CO is present, this you keep in mind. CHO, O is there, here also ketonic group also, CO group is there, carboxylic group. Then these I have told you some common these things, groups. Then now you might have understood meaning of 3-methyl octane. Then you can put the number from carbon 2, 3, 4, 5, 6, 7, 8. Just above the carbon you write that one number. For the first carbon 1, second you write 2. Above the carbon just write 2, 3, 4, 5, 6, 7, 8. Then third carbon methyl group is attached. Third carbon, one hydrogen gone, and its place methyl CH3 group has joined. That's why this compound is called 3-methyl octane. 3-methyl octane means on octane methyl group is attached. Like that way many compound will be there, and one hydrogen will go, and its place other group will come. Okay, then compound's name will be different compound name will change with a group, correct, and with carbon number also it will change, how many carbons are, chains of how many carbons are there. Then here I told you 3-methyl octane. Like that way you can also write, you can sometimes actually one this I want to tell you about the homologous series. Homologous series, I will tell you details at right place, but here I want to tell you that this sometimes hydrocarbon will be in a zigzag fashion, ZIG, zigzag fashion. The only atom specifically written are oxygen, chlorine, nitrogen. These atoms are specifically, they will specify, specifically written. Okay, oxygen, chlorine, nitrogen. That the terminals means last, first and last. The terminals denote methyl groups. Already I told you, and all are called alkane. Alkanes are saturated. Always keep in mind, alkanes are saturated, means all four carbon will engage with all four valency. Okay, maybe double or triple, but in alkane all will have single bond, and if carbon carbon double bond is there, then alkene. Already told you, alkene. If carbon carbon, between carbon carbon triple bond is there, then it is called alkyne. Okay, then I told you that terminals denote methyl group in case of alkane, and functional group may be also attached, while the line junction denote carbon atom bonded to appropriate number of hydrogen required to satisfy the valency of carbon atoms. Okay, then other zigzag, the example I am telling you, it will be just like you can tell CH2 down, one CH3, first CH3 you can write in down, and again one after that CH2 will start, it will go up, next carbon will come down, again after that carbon will go up, again next will come down, again it will go up, again next will come down, again it will go up, just like V, you are writing V in a reverse way, and see it will come in seeing like that, many V are there like that way, that CH3 down, CH2 little up, just like a V, big V are writing a little 1 centimeter, 2 centimeter or 1 inch, you can give the can say distance length, CH3 and just like a V structure, reverse V, and again it will come down 1 inch, same bond length, again it next will go up, again next will come down, again up, again down. Wave you have seen, na? Just like wave, but wave is not pointed, here is a pointed. Okay, just like a reverse of V, continuous. Then this is called zigzag structure, and this zigzag structure, in that also with any one carbon other group may be attached, one hydrogen will go, another group will attached. Okay, then now one more example I am telling you, that sometimes these things they will not write, you will not find that CH3 or CH2 is written there, you will not find, only point you will find. Everywhere point will be there, it will be not mentioned CH3 or CH2 like that, it will not mention, only point line will be there. Just like directly V, reverse inverted V you can write, inverted, just like one start with 1 point, second point, again third point down, fourth point up, fifth point down, 6 point up, 7 point down, 8 point up, and nothing will be mentioned here, no C mentioned, no H mentioned, only carbon will be there, this only point will be there, But here, in the beginning and last, you have to understand means terminals, that is the methyl group CH3. It is understood. This is also one way to represent you can say organic compounds, particularly alkane. That is, this is called, all things are called condensed or bond structure formula. This is also, but here it is these things, nothing is mentioned. Simply you have to understand that begin first is the CH3 and last is also CH3. That is called terminals. Terminals represent methyl group. Terminals represent methyl group. And again, suppose with this zigzag, this is called zigzag fashion. Then suppose in this zigzag fashion, a methyl group is attached. Then that methyl group also will be not mentioned. Only there one line they will write, one line they will put. That is understood. That also called, this is a skeleton structure, a skeleton. Then this one line for the methyl group, they will not write, it will not mention CH3. Only one line will be there. With the CH, suppose CH2 group was there, that is also not mentioned. But from their point, from that point, one line they will draw. It means from there, from that carbon CH3 group is attached. Just like 3-methyl octane, you have written a third carbon methyl group is attached. Then here also first you have written zigzag fashion, just like a inverted V. Then where third carbon, one line will be there. That will show a CH3 group. Okay, and these are the three things I told you. That is the representation of the organic compound. Now, other way I am telling you these things. Various ways of representing 2-bromobutane. 2-bromobutane, how will you write? Then 3 way you can write. What I told you now, that way 2-bromobutane. Then butane means what? 4 carbons should be there. ANE means alkane. Alkane means saturated carbon. 4 carbon atom will be there, and all carbon, 4 valency is engaged. 4 valency is engaged. All are single bond. No double bond, no triple. Alkane means only single bond. Then now, how will you write 2-bromobutane? Then 4 carbon first you write. 4 carbon. Then first and last will be CH3. One way I am telling you. First way, 4 carbon you write. Then first and second will be CH3. And in the middle 2 carbons are remaining. Then CH2, because already 2 valency is engaged with other neighboring carbons, already bonded, and 2 are remaining valence. Then CH2 has come. CH2. Then this is actually, you have written butane. 4 carbon means butane. Now 2-bromo you have to write, 2-bromo. Then carbon number 2, 1 hydrogen you remove, and in its place 1 bromine you write. Br. Then now, because on carbon number 2, bromine is there. That's why it is called 2-bromobutane. Then this is the one form to write the this thing condensed. I am telling all are the condensed. Then this is the first way to write condensed formula. Means now you can write in a simple way, CH3 CHBr because 1 hydrogen gone and 1 bromine came. Then On the second carbon, one hydrogen, one bromine is there. Then in a condensed form, you have to not write the bond. You have to not write the dash. Only because it is condensed. Then CH3, CHBr, CH2 and last will be CH3 without mentioning dash. No dash. Then this is the one way. And second way, how can you write? Then zigzag form. Means up, down, up, down, up, down. In that way, 4 you write. You start with CH3, down, and then one CH will go up, again down, again up. Then one CH3 will be up, other CH3 will be down. Means terminals will be, one will in opposite way it will be there. If one is up, other will be down. Then in that second carbon, Br you can write. C means you can write CH3, suppose you have written up, then CH will come down. And with that second carbon, Br is attached. Third carbon will go up, CH2. Fourth will come down, CH3. This is the second way to write the condensed formula. Third, then I told you that third will be just like they will, here it will be, one should not mention the, you can say carbon or hydrogen. Only point you have to mention. Point and a line. Point and line. Then beginning and end I told you, line point will show CH3. And middle you have not written CH2, only point is there, no CH2. Then that is understood. Middle will be CH2 only. Terminal will be CH3, understood. That point is telling CH3. And in the middle where point is there, V you are writing, V type. Then point. Point will tell CH2. Only end will tell CH3. Correct? Then beginning means terminals point will tell CH3. And middle points will tell CH2 like that way. Then here third I am telling you to bromobutane. Then here again you will write just like a V form without writing the bond, these things, C and H, only line will be there. Then first you have written first point and line dash you have written. Dash. Again you will go up. Then that point that is the second, from that Br will be attached. That time Br you can write. Methyl group you should not write. If you will not write anything, and line you will write that is a methyl group is attached. But other than methyl, any group will come, then you can mention it, like a bromo, fluoro, chloro, bromo, iodo. Other group you can write COOH. Then here you can write 4 points you have to mention. Then first point is CH3. Second point, suppose you are starting with up, then down is the second point. Again up you will go. Then second point Br you can write. Third went up. Again from up you came down. Then down means again CH3. Then in the middle it is understood that it is showing CH2. Then this is the third way to write the condensed formula. Okay. Now cyclic, last class I think I have given hint. Cyclic compounds, how will you write? Then it is very easy to write. Then just like a triangle, you make the triangle. Then each point is telling about CH2. Each point is telling about CH2. 3 points are there. Then each point you can write CH2 first point. Second point CH2. Third point CH2. Why? Because all carbons are attached to each there. Then 2 valency is engaged. Then rest 2 valency is joined with hydrogen. 2 valency is used up in making bond with 2 neighboring carbon. two neighboring carbon, two bond, means two valency is over. Always you count the valency, never you will get confused. Then one carbon is attached with the two neighboring carbon, the two valency is over. Then now two valency, for two valency, HH you can write. HH you can write. Then now four valence is clear. Two valency, two hydrogen is there, means two bond, and this two bond, total four bond. Carbon, two bonds, and two bond with hydrogen. Then like that way, on each point you write CH2, CH2, CH2. This is the one way to write cyclic compounds. Other way, you don't want to write CH2, don't write. Only triangle you write. CH2, that one triangle you write, 3 points are there. 3 points are there, then it is understood each point is CH2. Need not require to write the CH2. Only point, 3 point and join it. Make a triangle. That is also, both are correct. Both are correct. Higher level, only just triangle you have to write without CH2. Okay, generally at lower classes you should mention CH2, but if you will not mention also, it is understood. But in lower classes, if you write only triangle, then sometimes doubt will come whether students are knowing both concept or not. Hence better you write CH2. But you can write one triangle also, that will be correct. Then this is the for you have written one way. I told you that because 3 carbon is attached, 3 carbons are involved, then, and it is in a cyclic form because all are joined to each other. That's why it is called cyclopropane. Propane may be a straight line also. But here is in a cyclic form. All are joined. That's why it is called cyclopropane. Like that way, cyclopentane you can write. Cyclopentane means 5 carbon will be there, and each point will be CH2, 5 points, all joined. All carbon is joined. Means this you can say two carbon left side, 2 carbon right side, and 1 carbon up. Okay, 5 you are writing pentane, pentagon like that, means 5 points you write, 2 left side, 2 right side, and 1 up, and all you joined. Then you will get 5 bond. 5 bond you will get. Down both carbon is joined, then 1 bond. Again, parallel way, what you have written, 2 carbon both sides, that you join, and from up. Total 5 bond will be there. Name itself is there, cyclopentane, because all are single bond. That's why it is a, and it all are joined. That is why cyclopentane. And each point CH2, 5 will be there. Then here also same way you can write. If you don't want to write CH2, then only pentane structure, just like triangle structure you have written. Here 5 points just to join simply without writing CH2. That is also correct. Like that way, chlorocyclohexane you can write. As for example, you have to write chlorocyclohexane. Then try to understand. First you understand this is the hexane. Hexane means 6 carbon is there, but it is in a cyclic form. Cyclic form means all carbons are joined to each other. Then how will you write this? Then 2 carbon one side, 2 carbon other side, 1 carbon up, 1 carbon down, and all you join to each other. Then you will get 6 sides, just like a square, 4 sides are there. Pentane, 5 sides are there. Here 6 sides you will get. 2 carbon left side, 2 points left side, 2 point right side. Correct? 4 carbon and 1 carbon up, above this two line and one down this two line, and all you joined, and every point you write CH2, 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 total 6 point means 6 CH2, and then this is actually cyclohexane. AN is there, means alkane everywhere, single bond is there. Now chloro, if you want to write chlorocyclohexane, then anywhere one hydrogen you remove and its place one Cl you add. Suppose in the top CH2 was there, everywhere CH2 is there, 6 points means 6 CH2. Then from anywhere one H you remove, only one only CH will be there, and its place one chlorine you add. In the place of one hydrogen, one chlorine will come. Then now in that point it will be CHCl, one chlorine will be added. Then there one hydrogen only will be remaining and one chlorine will come, Cl. Then that is called chlorocyclohexane. Chlorocyclohexane. This I have told you. This is also way to represent cyclic compounds. Like that way, now for the practice purpose, it is there. Problem is there only for practice purpose, that you can use, that you can write very easily. This is a problem just only for practice purpose. As for example, I am telling you, question is given, expand each of the following condensed formula. Expand each of the following condensed formula into their complete structural formula. Condensed formula they have given, and a structural formula you have to write. Means when you will write the this bound dash, you will write, that is called a structural formula with bound, with dash. Dash, that is a bound, it represents the bound. Then in that way, that is called a structural formula. Then condensed formula they have given, and you have to write a structural formula. Then two questions are there. First they have given CH3, CH2, CO, CH2, CH3. See how easy is to write. CH3, total 1, 2, 3 carbons are 3, 4, 5 carbons are there. Then with the third carbon, oxygen is attached, means CO, double bond will be there. Oxygen has two valency. That's why generally it will make double bond. Okay. Sometimes single bond also they can attach two group. In the middle it will come, one left side, other right side. Otherwise, generally if it is attached with branch, then it will make a double bond, means two valency will be over. Carbon 2 valency will be used up with oxygen, only 2 will be remaining. Then now that's first question I told you, CH3, CH2, CO, CH2, CH3. Then I think you can write very easily. CH3 you can write C, first carbon is CH3, C, and then 3H you join with 3 bond, 3 dash you write, C and H 1 dash, and another C and H another, and third C and H, like that way. Last you write, last total 1, 2, 3, 4, 5 are there. Then 5 carbon first write, and first and third you write CH3, 3 bond you write, and in the after that second and fourth, because in the third carbon oxygen is attached, and then see double O, either down or up. This oxygen you write up or down of carbon, no problem, but you have to mention double bond, CO, C and O, 2 line you write. And now first and third you have written, and middle you have written. Then now second and fourth, CH2 you have to write, CH2 means one hydrogen up, one hydrogen down of carbon. Then like that way you have written the this structural formula, condensed formula they have given, a structural formula you have written. Now second is that, second question B, A and B, then CH3, CH, double bond is there, again CH2 whole 3 is there, and again CH3 is there. Then how many carbons are there total? Then CH3 1 carbon, again CH 2 carbon, and again CH 3 carbon, again CH2 whole 3, CH2 whole 3 means 3 carbon again, then 6 carbon, and end is the CH3, 7 carbon, 7 carbon straight away. Then now first to write 7 carbon. Before writing, just to think 7 carbon to write, because you have to change. That's why only in the mind you have to do all the thing. But 7 carbons are there, that you keep in mind. Okay. Then 1, 2, 3 and 3, 6, 7 carbons. Then 7 straight carbon you write, C, straight. Okay. And after that you see carbon number 2, and just also in mind you count carbon 1, 2, 3, 4, 5, 3, 6, 5, 6, 7. Okay. 1, 2, 3, 4, 5, 6, 7. Then here you can see in question carbon number 2 and 3, between carbon number 2 and 3 double bond is there. Then you write a double bond. You have done important work. And after that this third carbon onward, they have written CH2 whole 3, means 3 times CH2 you have to write, CH2, all are joined by single bond, all carbon is joined by single bond. And now CH2 is there, then up 1 hydrogen, down 1 hydrogen is joined by dash, CH, again CH, last already you have written, first and last CH3. Then see, only one double bond has come between second and third. Then like that way you can solve, you can say many problem will come, may ask in examination also, but this is the simple. Sometimes complicated also they can ask. Another question is there, problem is there, that is you should be careful, and it is not very tough. Same things you have to follow. I am reading a question. For each of the following compounds, write a condensed formula and also their bond line formula. Okay, this bond line formula, what I told you, a skeleton, that is also called a bond line formula. Okay, only other than methyl group, if it is there like chloride, bromide, iodide, only, or OH, COOH, this you have to mention in the skeleton structure with only point as a group. But methyl, ethyl, this you have to not write. In methyl you have to not write, ethyl you can write. Then now you in this question you have to write two formula, condensed formula, and you have to write bond line formula. Then condensed formula, how will you write? Question is that OH, in the beginning OH is there, OH is attached with CH2, and again CH2, after that CH is there, then again CH3 is there, again CH is there, again CH3 is there, and again CH3 is there. Means here if you count how many carbons are there, then 1, 2, 3, 4, 5, 6, 7, 8. 8 carbons are there. But here you have to be careful, because that if it is a straight, then only 2 methyl groups should come in the beginning and last, CH3. But here if you see the question, then there it is written that 2 times CH3 written. Total 3 times is there, 4 times. One is in the beginning, other in the last. That is okay, that is not a problem. But 2 more CH3 is written in the middle. 2 more CH3. What does it mean? This is now beginning and last CH3 will come. A straight line, that is understood. But 2 more CH3 is given. Because they have written OH is in the beginning. One carbon is attached with OH. Okay. After that CH2 is there. Again CH2. Again CH2. Then again CH2 should come. But there in the place of CH2, one CH they have written. Other H, in the place of other H, CH3 group is attached. As just like a branch. That's why they have not written CH2, they have written CH and one CH3. It means this CH3 is as a branch, down or up. With carbon it is attached. With for one hydrogen, one CH3 has come as a branch. You can write either above or down, not a problem. Again CH2 should come, but CH2 has not come. Again CH written and again CH3. It means again it is also, this CH3 is also in the form of branch. You can write upside or down, no problem. Then 2 branch is there. 2 hydrogen replaced by 2 methyl group. 2 methyl group. Okay. Means carbon number first is attached with OH group. OH group. Second is not a problem. Third is not a problem. Fourth carbon, fourth CH2, the one H is okay. Other H is attached. Fourth is attached with methyl group. And fifth is also attached with methyl group. Hence, now if you want to write condensed formula according to the question, then for each CH2, just to count how many CH2 is there, and then whole you write. As for example, OH, CH2, CH2, CH2 is there. Then here you can write, how will you write condensed formula? Then OH you write, and after that 1, 2, 3 CH2 is there. That CH2 whole 3 you can write. CH2 whole 3. In the beginning you write OH, and after that OH you can write HO also, no problem. In the beginning you should write HO. Okay, in the middle OH. In the middle and the last OH you should write O and then H. But in the beginning you should write HO. Okay, oxygen has 2 valency. One is joined with H, other is joined with carbon, HO. Then now I was telling you how to write. Then HO and then 3 CH2 is there. Then CH2 whole 3. And after that CH, CH3. CH, CH3. CH3 is in bracket. You write in bracket only. Same way now you continue. Nothing you have to do anything. Copy it same way. Only HO, and after that CH2 3 times was there. Then CH2 whole 3 you write. Then complete will be like this. HO, CH2 whole 3, CH, CH3, CH, CH3. But here in the last, because in the last 2 CH3 is coming. In the first is the CH, CH3 one time. Second time CH, CH3 is there. Again last is also CH3. Hence both CH3, now you can write CH3 whole 2. CH3 whole 2. Because 2 times CH3 is there continuously. Hence you can write CH3 whole 2. You try to minimize it. That is called condensed. You have just like a gas condenses, becomes less volume. Like that way, bigger structure you are making short structure, short way. Then this you have written the condensed formula. Now another question is there. Another way I told you, you have to write also bond line formula. Bond line formula for the same question. HO, CH2, 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 CH3, CH3, again CH3. Then you have to write bond line formula, just like a skeleton you can tell. Then here OH is there. Then how many carbons are there? Total I told you that time. 1 carbon, 1, 2, 3, 4, 5, 6, 7, 8 carbons are there. Then now again you start with writing like the from the beginning. Start this from the down you start, up, again down, again up, again down, again up and down. First to write simple, means total how many? Total 8 carbon you have to adjust, but in that 2 are branch methyl group. 2 are branch methyl group, means 6 point you have to first to write. 6. Total 8 carbons are there, then 2 are the methyl group. That is the branch. Hence main, that is also called parent branch. Okay. Then that will be 6. 1, 2, 3, 4, 5, 6. Then in the beginning point, you add OH, join OH. Correct? In the first carbon point, OH you write HO. HO should attach with, should write near the carbon, near the first carbon, first point. Then second point you have to not write anything. Third point also you have to not write anything. First point HO you have written, second point don't write, third is the down, don't write, fourth also nothing, fifth and sixth continuous, fifth and sixth CH3 was there, CH3 was there on fifth and sixth. Okay, then there you have to write one line with fifth and sixth carbon. 1 carbon, 2 carbon, total count 1 carbon, 2 carbon, 3 carbon, 4 carbon, 5 carbon, 6 carbon, 7 carbon, 8 carbon. Correct. 8 carbon there. 1 carbon, 2, 3, 4, 5, 6, 7, 8. Then like that way, where you can say CH3, which carbon CH3 is attached, there you write only one line, a small one line, just like that will show that methyl group is attached. And again next carbon methyl group was attached, then there upside, one upside, one down, you can write both again, better one down and up. Okay, same meaning. Then one line up, one line down, fifth and sixth you can write attached, one line you write. That is telling about the branch CH3. And last point is telling about the CH3. Then this is called bond line formula. I will try to send this type of structure. Now another question is there, NC, N and C triple bond is there, and after that single bond CH is there, and as a branch OH group is attached, and again single bond is there, again CN is there, triple bond. Correct? Means 2 triple bond is there, 2 triple bond. Carbon is only 3, and with first and last carbon nitrogen is joined. Then first carbon N and C, actually CN is the cyanide group, that is CN is the cyanide group. Then this 2 CN is attached, then first CN is there, means NC you can write just like HO. Whenever it will come in the beginning any group, then that you write with reverse case. Generally it is a CN, then there you can write as a NC. Then N and C triple bond is there. After that N and C triple bond means 3 valency of carbon is already used, and nitrogen has 3 valency. Then for nitrogen no problem, carbon 3 valency is used, this N and C, 1 more valency is remaining for carbon, then that is joined with other carbon, second carbon. then now that is also used. No H, only this is sufficient. And that carbon, second carbon with that is attached with another carbon. Then now 3 and 1 carbon has joined OH, and 3 valency is used. 3 valency is used for the second carbon, because one left side, one right side, they joined with carbon. 2 is over, third one is with OH, and for the fourth one H is there. Then now this is also, it is very easy to write the condensed formula, because you are knowing that okay, there is a repetition of the CN group 2 times. Then obviously, how will you write? Then you will write that CN 2 times you will write. OH 1 time you have to write, because only one OH is there. OH CH. OH CH you have written. These are the only one time OH, 1 time CN, then OH CH, and CN 2 times, then CN whole 2, OH CH CN whole 2. This is the condensed formula. Okay, OH CH CN whole 2. This is the condensed formula. And for this same molecule, what is the bond line formula? Means a skeleton bond line. Then it is very easy to write. Here with 1 carbon is in the middle, and with that carbon 2 CN group is attached, and 1 is OH group attached. OH is attached, means out of 4 valency, 3 valency has 3 group. From the out of 3 valency of carbon, there are 4, 3 are used. That 1 is joined with OH, and other 2 is with CN, and fourth one is with H. That you have to not write. For H and CH2 you have to not mention. Okay, in a skeleton structure, for H you have to not mention at all, whether CH2 or CH, whatever be. Then now it is just like, it became just like in the middle one point you write, that is showing 1 carbon and 1 hydrogen. Why? Because now from that point 1 OH group is attached. Upside you have written OH, and left and right down, just like a V structure. V structure, inverted V structure. Inverted V structure you have written. Then down, both down you write CN, and upside you write OH. Then now you can see carbon valency, it appears 3, but for H it is not mentioned. It is showing CH only down. 3 groups are there. In the fourth one is hydrogen. Carbon is attached with 3 group. One is OH, other is CN, and again second is CN. 3 is used. Then fourth one will be H, that you have not mentioned. And this is the way how to write the condensed formula and bond line formula. Now this again for the, actually it needs more practice. It needs more practice, only then you will understand. And now I am telling you another problem. Then here question is given, expand each of the following bond line formula to show the atoms including carbon and hydrogen. Again I am reading the question. Questions are easy. In competition, this type of question will ask. Organic chemistry questions will be like this only. Keep in mind. And say you should try to understand the concept. Concept is very, very important. In the all organic chemistry, concept is very, very important, because they will form many different of compounds will there. You can't memorize. You can't remember all. But concept, if you are knowing, then easily you can solve. Then here again you listen the question. That is the, I think, last question. This I will discuss. Okay. Then here first question, the question is that expand each of the following bond line formula to show all the atoms including carbon and hydrogen. Now they have given a skeleton structure, means now it is given this bond line formula they have given a structure. Now you have to mention that all atom you have to mention. Now I told you for the point was in the beginning, point was CH3, last was the CH3, and in the middle CH2. And if one line is attached, only one line is there with any carbon, that is showing CH3, unless if any other group is attached. Then now you have to mention now this formula they have given, bond line formula is given, and you have to write the this atoms you have to mention. Formula, chemical formula you have to write, means you should write the atom. Then now here first question is there, that is that they have given benzene structure. Benzene structure is there, 6 points are there, all are single bond. Hexane, you can tell, hexane they have given, cyclic structure they have given, means all 6 points are joined to each other. All 6 points are joined to each other, means each point single bond is there, and only from one point one line they have written, and after, means one bond is there, after that again another point is there, from that two line is there, means just like hexane they have written complete hexane, but from the one carbon one can say bond is there, and after that from that bond you have written, where bond is ending, that point is the carbon. Actually it will show carbon, but here from that end that line where line is finishing, that point is carbon. From that two lines are there. Then one line means CH3, one line means CH3. Then now what will be the, you can say, formula? What will be the formula? You have to mention the atom. Then very easily you can mention each carbon, everywhere single bond is there. Each carbon you can write CH2, each point you write CH2. Then hexane formula you write, but every corner now you write CH2, CH2. 5 corner you write CH2. 2 hydrogen you have to write everywhere. 6 carbons are 6 points are there, but 5 you write CH2, CHH, and sixth point again you write carbon. But here 3 valency is over, only one hydrogen you have to mention, because that 2 carbon is already but neighboring carbon it was attached, and here it is attached with another carbon. Fifth carbon is attached with one more carbon. Then only 3 valency is now over, only one is remaining, that is for H. Hence there also we write C and one H, and from there one carbon is joined, one point is there, then you write CH, because 2 CH3 group is attached from that carbon. Then when 2 CH3 group is attached, then now 3 valency is over. For that carbon 3 valency is over. CH3 2 branch, CH3, and one C is attached with the hexane ring. Then 3 valency is over. Then fourth one is H. fourth one is H is remaining. Hence, everywhere, wherever point was there, you have written CH and valency you count. Simply, for valency it is satisfying or not, just to check it. Then now, your final answer will be CHH, means CH2, again CHH, third carbon CHH, fourth carbon CHH, fifth carbon CHH, sixth carbon, from the sixth carbon, another one line has come and carbon is attached. Then for the attached carbon, from that attached carbon, 2 methyl group is attached, CH3. Then now, valency you have to, for valency you check it. Then sixth carbon of the hexane has only 5. 5, you can say, not sixth carbon of the hexane has only 3 valency. Then fourth one will be hydrogen. Okay. And here, with sixth carbon, hydrogen is attached. Then from that, 2 branches there. Then 2 branch and 1 is attached with the sixth carbon. Then 3 is engaged. Then fourth one will be H. Okay. Like that way, again they have given very question next, only in that 4 questions are there. Then B, A I told you, B they have written only just like these things, simple way, V, inverted V, down, up, down, up, down, up, down, up. Means total carbon is 1, 2, 3, 4, 5, 6, 7. 7 carbon is, 7 and 8 carbon is there total. 1, 2, 3, 4, 5, 6, 7, 8. 8 carbons are there, but they are in a zigzag form. Zigzag means a skeleton, what you are telling, that way. Okay, down, inverted V like that. Down, up, down, up, down, up, down, up. Then it is very easy. Nothing is written. Every point you fill it CH2. That's enough. Every point you fill it CH2. And it becomes CH2, 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 CH2. Last is also, and first and last will be CH3. First and last will be CH3. Every point will be CH2. Okay. Then it is very easy to write this. Now one more, this third C and D, 2 are there. Then second was very easy. Third one is that in the beginning only triple bond is there. Triple bond is there only in the beginning. After that, single bond is there. It is also zigzag, inverted, like that way. The beginning is the triple bond. And after that, single bond. Between the double and single bond, carbon will be there. Nothing is mentioned, means carbon. And after that, again single bond. And after that, again down they have written OH, branch, OH. And after that, from that carbon, again you can say, last one line is there, that is the CH3, last carbon means CH3 only. Then CN means what? CN means triple bond. CN means triple bond. Then that is the carbon triple bond. After that, C is there, then CH2, again C is C is there, and one OH group is attached. OH group is attached, that is the branch. Then OH you write, again in the end carbon, that is the CH3. Then finally we will get, if valency you count for valency is satisfying or not. Then see, first is the triple bond, carbon is there, carbon triple bond. Then that is the only 3 bond is there. Then fourth valency you write H. Then in the beginning it became HCC triple bond. After that again CH2, you know that HH you have to add again. Next is the COH, means now 3 valence is there. The fourth one will be H, and in the end CH3. Then like that way, you can write very easily. And one last is there, that is they have written 2 points are there, and with each point branches are there. For each point 2 points are written. When a line is there, then 2 point first point, second point, on a line is only, and from each point 2 lines they have given. Then lines means CS3, then you write like this, from each point CS3 attached, then 4 CS3. Then now, and both carbons are attached with 1, then 3 valence is over. Then fourth one, then for the fourth one you attach H for both carbon, then now it became, each carbon has 2 CS3 and fourth one is H. Okay, both and carbon same things. CS3 1 H, 4 valence is over. Other carbon also same base, CS3 H. Then today I am stopping only here. Again next class we will discuss with other representation of organic molecule. Thank you.